Usually these complexity classes are important. So if the time complexity of algorithm is big O of 1, then it means that the algorithm runs in constant time irrespective of the input. Which means that even if you have 10 input, 10,000 input or 1 lakh input, that doesn't affect the running time of the algorithm. That is constant time. That is the meaning of constant time. So if you represent it as a graph, input size, inputs on the x-axis and running time on the y-axis, and inputs on the x-axis, you will be getting a graph like this. Constant time, irrespective of the input, the time complexity will be a constant. So line will be somewhere here, can be anywhere depending on the algorithm. Then you have another important complexity class is linear. Linear complexity means it increases with the number of inputs. So for the graph of linear will be like this. That will be a straight line. This is linear. It is order of n. This is constant. That is order of 1. Then you have important one is quadratic. Quadratic is it increases faster. So it will be something like order of n square. So you can draw like this. Quadratic or order of n square. So you can see that linear is better than quadratic with increase in inputs. Then there is something called exponential, which increases much faster. Exponential. So these are not preferred type of algorithms. Exponential, order of 2 raised to n. Likewise, exponential. Then another important class is logarithmic, log n. So it will be like this. This will be a straight line. Logarithmic. That is order of log n. These are the important complexity classes. This graph is also important.